Dear colleagues, dear guests, let me start the dissertation committee meeting dedicated to the defense of the dissertation of Nikita Valerievich Sandalyuk, seeking a degree of Candidate of Geographical Sciences in the degree field 250028 Oceanology, on the topic a study of the mesoscale variability in the dynamically active regions of the world ocean based on the altimetry and in situ data. According to the acts of the Academic Secretary of St. Petersburg University, Alexander Valentinovich Gnetov, dated 25th February 2021, I, Evgeny Alexandrovich Zakharchuk, Doctor of Geographical Sciences, Professor of the Department of Oceanology, St. Petersburg University, was appointed chairman of the dissertation committee, and other members of the dissertation committee include Vasily Vasilievich Dmitriev, Doctor of Geographical Sciences, Professor of the Department of the Hydrology of the Land, St. Petersburg University, Leonid Alexandrovich Timokhov, Doctor of Physical Mathematical Sciences, Professor of the Arctic and Antarctic Research Institute. Online with us in the remote mode are Sergei Ilyich Badun, Doctor of Physical Mathematical Sciences, Chief Research Fellow and the head of the Laboratory of Nonlinear Wave Process of the Institute of Oceanology, the Russian Academy of Sciences. Can you see and hear us? Yes. Alexey Vladimirovich Zimin, Doctor of Geographical Sciences, Professor of the Department of Oceanology at St. Petersburg University, and Evgeny Vladimirovich Yakushov, Doctor of Physical Mathematical Sciences, Research Fellow of the Norwegian Institute of Maritime Studies in Norway. Also, Nikita Valerievich is present with us here in the hall, and also the academic advisor of the candidate, Tatiana Vasilievna Belanenko, Doctor of Geographical Sciences, Professor of Oceanology, Department of Oceanology, St. Petersburg University. To improve the quality of communication, I would like to ask all our colleagues who are on emoji mode with us to switch off your microphones, but don't forget to switch them on when you're given the floor. I would like to mention that a live broadcast accompanied with simultaneous interpretation between Russian and English is on the website of St. Petersburg University. Also, there's an email address where you can send questions to the or comment to the candidate during the session of this gestation committee. But these questions or comments should directly relate to the issues discussed. The technical services will transfer them to me, and I will read them. And the questions should completely cover the dissertation and also the affiliation and the names of the people who have asked the questions should be present in the email. All questions that have no relation to the dissertation or the presentation or anonymous questions will not be read. In accordance with the procedure of awarding academic degrees of Doctor of Science and Candidate of Science, the dissertation committee session is legitimate if not less than 2/3 of the established membership of the dissertation council are present, but not fewer than 4 people. Our dissertation committee consists of 6 people. All 6 people are present, including 3 in the distant mode, with all the members of the dissertation committee and the candidate are in audio-visual contact with us, so the quorum is there. I would like to go over the agenda. 2 hours as the duration of First item on the agenda is a short presentation of the chairman regarding the paperwork that has been submitted by the candidate. 5 minutes. A short presentation of the candidate covering key issues of the dissertation. 15 minutes. Questions to the defendant, strictly on the presentation, not more than 2 minutes per question. Answers of the candidate, not more than 5 minutes per all questions. Then all members of the Dissertation Council will take turns reading their reviews, including the chairman. 10 minutes. And they will view review the dissertation answers of the candidate, addressing the issues raised in the reviews. Open floor discussion. Anyone present will be able to state what they want or ask their questions, but strictly on the topic of the not more than 2 minutes per speaker. But in order to do that, you should enter your name into the logbook. And when you start your comment, then you should introduce yourself. Then 9 is reading out the questions that have arrived via email. And I would like to remind you that questions that would take more than 2 minutes to read will not be read. Answers of the defendant to these questions, and then a dissertation advisor will have 3 minutes to talk about the candidate, and then there will be a deliberation period when the broadcast will be switched off to discuss the verdict. Then there will be open roll call voting, and then a verdict is achieved to award or not to award the degree, and then the concluding statement by the candidate, not more than 2 minutes. Dear colleagues, do you have any questions or objections to this procedure? You said 15 minutes is the duration of the presentation, approximately. If there are no more objections, then I would like to ask you to switch off the sound on your mobile phones. But those people this is for those who are here, but those people who are in remote mode with us, do not switch your phones for emergency communication with you. Well, the first item, the dissertation of Nikita Valerius Sandalyuk, seeking a Candidate of Sciences degree in geography, oceanology, on the topic a study of the mesoscale variability in the dynamically active regions of the world ocean based on the altimetry and in situ data. Was accepted for defense on the 8th of February 2021. Nikita Valerius wrote his dissertation in St. Petersburg University, supervised by the Doctor of Geographical Sciences, Professor of the Department of Oceanology, Tatyana Vasilievna Belonenko, St. Petersburg University. The number of publications is 6 works in refereed, out of which 1 publication in the refereed Ministry of Science, the Russian Federation list of journals, and then Web of Science and Scopus, 5 publications. The candidate has submitted the full package of the documents to Alexander Vladimirovich Gnatov. Their totally comply with the requirements, and well, the curator of this dissertation council keeps the copies of these documents in the personal file, and they're available here for access. Before I give the floor to the defendant, the members of the dissertation council, do you have any general questions on? And do you think that we have to read out the whole list of the documents that were presented? No questions or objections. No questions. Then we turn to the short presentation of the candidate. Nikita Valerievich, 15 minutes are yours. Dear members of the dissertation council, dear colleagues and dear guests, I would like to present my paper of the dissertation on the topic of study of the mesoscale variability in the dynamically active regions of the world based on the altimetry and in situ data. Before I get to the substantial data, I would like to say a few words about the relevance of the research. Eddy processes play one of the key roles in ocean dynamics. Eddies are capable of capturing and transporting large volumes of heat and salt, as well as the biogeochemical characteristics, therefore having a significant impact on both regional and global climatic and biological processes. Mesoscale vortex activity is one of the main mechanisms of horizontal and vertical mixing. However, to date, the comparative contribution of linear and nonlinear process in the ocean, the influence of regional features on the generation and dissipation of eddies, the nature of the interaction of mesoscale eddies with currents and bottom topography, assessment of heat and salt transport carried by eddies has not been sufficient studies. Therefore, one of the urgent tasks of Oceanology is the study of a special thermohaline structure of mesoscale eddies. My study involves 3 regions with different dynamic activity: the Golas current region, the Lofoten Basin region, and the Australian Antarctic Basin. The main objectives of my research is comparison of linear and nonlinear effects of the potential vortex conservation equation based on satellite altimetry data, a comprehensive analysis of mesoscale eddy dynamics for the Galhas flow region, as well as the obtaining of 3-dimensional composite structures of cyclonic and anticyclonic eddies, analysis of the 3-dimensional structure of mesoscale eddies forming in the Lofoten Basin region, and the 4th one is study of gradient eddy waves in the Australian Antarctic Basin using satellite altimetry data for the ocean Rossby waves and for the coastal zone of the ocean trapped chef waves. In my work, I use data from satellite altimetry measurements, as well as data from an ANR obtained based on the application of the automatic vortex identification algorithm. And the vortex identification method is based on the principle of vortex detection and the fields of anomalies. CDT profiles from Argo buoys were also used for the Galhas flow region. A few words. The array obtained on the basis of the automatic identification algorithm includes the main characteristics of the vortices, the most important of which for my research were the vortex polarity, radius and coordinates of the vortex center. And studying the 3-dimensional structure of mesoscale eddies of the world ocean is still a non-trivial task due to the difficulty of obtaining a sufficient number of profiles within a single eddy. For this reason, in 2011, Chanyo et al. Presented a method of composite structures, the essence of which is to obtain an average three-dimensional image of a mesoscale vortex for the region under study. To obtain composite eddy structures, I developed an algorithm that compares two types of data: hydrological profiles and data from an automatic identification algorithm named data on the location of eddy centers. Each profile was associated with the nearest vortex if it met two conditions: the profile and the vortex have the same observation date, and two, the profile is located within a distance of 1 radius from the center of the vortex. As a result, sets of profiles were identified separately for cyclonic and anticyclonic mesoscale eddies, which were then interpolated into a grid, served as the basis for obtaining composite thermal eddy structure. For the first proposition is to be defined estimates of the contribution of linear and nonlinear terms to the equation of conservation of a potential vortex circulated for different regions of the world ocean using satellite altimetry data. The equation of conservation of potential vortex serves as a mathematical model for describing a synoptic process. The main idea of this work is to estimate the contribution of linear and nonlinear terms to the variability of the level field. If the second term, Jacobian, dominates on the left side of the equation, we're dealing with nonlinear vortex structures. If the third term is dominated by the linear term, which characterizes the contribution of rows of waves, then we have a different story. Comparison of the contributions of linear and nonlinear effects in the equation of conservation potential vortex showed that no linear effects dominate on the low frequency level variability. This in turn confirms the conclusions of Shelton's study and the significant non-linearity of mesoscale structures. And second statement for defense: three-dimensional composite structure of cyclonic and anticyclonic eddies of the Lofoten Basin. The Lofoten Basin is the most dynamically active region in the North Atlantic. The quasi-stationary Lofoten vortex is located here, which is traditionally a subject of heightened interest for ocean scientists from all over the world. My research focuses on mesoscale eddies that form when they separate from eastern branch of the Norwegian current. Also, the separation of eddies from the mainstream contributes to the gradual cooling of the Norwegian current on its way to the Arctic Ocean, which in turn has significant impact on the climate of the region. As a result, for the first time, three-dimensional thermohaline structures were obtained for anticyclonic and cyclonic eddies for the region under study. The main feature distinguished from the obtained structure is the symmetry of the vortex core, which is observed both in the composite cyclone and in the composite anticyclone. Apparently, the observed structure is a characteristic feature of mesoscale eddies in the Lofoten region, which, due to the pronounced zonal gradient on temperature and salinity of the entire area of the Lofoten Basin. From the radial sections of eddies, we can distinguish the main features of the thermohaline structure of eddies in the Lofoten Basin, the location of the eddy core, and the depth of propagation of significant anomalies. Both anticyclones and cyclones have a significant effect on the thermohaline characteristics of the surrounding waters. And interesting features include a double structure in a cyclonic composite cyclone with the core of the salty water in the upper layer and less saline water at depths of more than 2 meters. Based on these estimates, the eddy transfer of heat and salt fluxes in the region was calculated, estimates of the volumes of heat transported by the anticyclones to the center part of the Lofoten Basin are presented here. Also, estimates of the seasonal variability of the semi-haline stature mesoscale eddies in the Lofoten region were also obtained. Of the remarkable features, it should be noted that the core of the anticyclonic and cyclonic vortex is significantly deepened, while its vertical size decreases and the core takes on a lenticular shape. If we divide the obtained picture of spatial transport into seasons, we can see that in winter there's a significant intensification of eddies transport, especially for anticyclones, which is obviously directly related to the intra-annual variability of the Norwegian current, which has a pronounced seasonal cycle. The third provision for defense is the classification of mesoscale eddies in the Agalhas flow area. Agalhas with the construction of composite eddy structure. This region is one of the most dynamically complex regions of the world ocean. It's characterized by a variety of dynamic processes. Here the formation of the Agalhas rings takes place, responsible for the transport of the salty and warm waters into the Indian Ocean from the Indian Ocean to the Atlantic. The main focus of my research was to study the nature of the spatial distribution of the generation and dissipation of vortices. The main regions of increased vortex generation are identified, and the dominant influence of topography on the process of vortex dissipation in the region is also determined. Composite structures for the rings of the Agalhas current were also obtained. And the anticyclonic core of the vortex has a powerful pronounced structure, which is typical for the rings of the Agalhas current. On radial sections, we can observe the characteristic features of the hermeline structure of eddies in the studied region. And the distribution of significant structures and salinity anomalies reaches 1,500 meters for an anticyclonic eddy. Among the most important results, it should be noted that the average estimates of the volumes of heat and salt carried by the rings of the Agalhas current correlate well with the results of the previous studies. As expected, zonal transport is predominantly westerly for both cyclonic and anticyclonic eddies. The maximum value of western zonal transport for anticyclonic eddies is observed in the Agalhas retroflexion region. And the last precision for defense. Characteristics of Rossby waves in the Australian Antarctic Basin. Estimates of shelf wave velocities calculated from satellite altimetry data.
Для выделенных вихрей была произведена оценка фазовой скорости различными методами. По методу Радон.
For the selected eddies, the phase velocity was estimated by various methods, by the radon method using the obtained isoplates, by the long wave approximation based on the data of the mesoscale eddies and altimeter to meet observations array. The empirical estimates of the velocities are somewhat higher than the theoretical ones. And the latter circumstance is due to the fact that in the indicated massif, the movement of vortex is taken into account not only in the zonal but also in the meridional direction. Shelf waves are typical examples of synoptic variability in the coastal area. Therefore, part of my research is the study of shelf waves in the Great Australian Bight. To characterize waves propagating on the shelf of the Australian Gulf, 2D FFT spectra were constructed from altimetry data along the 50, 100, and 200 meter isobaths. Note that the general estimates of the spatial and temporal scales of variability obtained in the study based on satellite altimetry measurements are in very good agreement with estimates of other authors obtained by independent methods. This means that this kind of data are usable. The theoretical and practical significance of the work, the capabilities of satellite altimetry data have been demonstrated both for studying surface characteristics of eddies and for obtaining vertical and horizontal distribution of thermaline characteristics and cyclones and anticyclones by comparing satellite and in situ data. The obtained three-dimensional eddy structures can be used in the future as a basis for studying the influence of mesoscale eddies in the biogeochemical process in the Gallas flow region and the Lofoten basin. The results obtained can be used to validate eddy resolving climatic models in the studied regions, and also to track the manifestation eddy in CDTD profiles. The results of the presented dissertation research can also be used to assess the biological productivity of waters. And the key conclusions, I already mentioned that during my presentation, is the comparison of the contributions of linear and non-linear effect. The equation of conservation of potential vortex showed that non-linear effects dominate in the low frequency level variability. At low latitudes, non-linear effects exceed linear ones by an order of magnitude, while at middle latitudes, these characteristics differ by 2 orders of magnitude. Significant temperatures and salinity anomalies in anticyclonic cyclone eddies and the Agalhas current are concentrated with a distance of 1 hour from the center of the eddy and propagate to the depth of 1,500 meters for anticyclones and up to approximately 1,000 meters for cyclones. And the analysis of composite structure of eddies showed in Lofoten basis maximum temperature and salinity anomalies in the anticyclone reach 1.0 degrees Celsius and 0.05 grams per at a depth of 600 meters. The eddy core is located within the depth of 150 to 900 meters. And the zonal factors transport has a predominant western directions. The temporal variability of the characteristics of mesoscale eddies in the Australian Antarctic basin is significant, no stationary, and the extrema can exceed the average values by 2 to 3 times. 13 academic articles were published covering the key issues or conclusions, 7 of which are included in the Scopus list. Thank you very much. Thank you, Nikita Valerievich. Any questions to the candidate, to members of the Dissertation Council? Leonid Alexandrovich Timokhov, I have 2 questions. First one is the vortex, eddy dynamics, or vortex dynamics, the only characteristic of the dynamic characteristic of the ocean. What are the reasons of vortex formation in Lofoten basin? Is it non-stable current or atmospheric impact? Thank you very much. Thank you very much for your questions. I'll start from the second. The reasons of forming a vortex, unstable of the Norwegian flow. Not only Norwegian flow, there are 2 currents, the western and the eastern, and they both converge, and so this they impact. Yeah, the eastern slope. The second question. Well, not only the vortex dynamics, but also shelf walls, Rossby waves are dynamic characteristics. But I focus only on these to complement as a follow-up to the previous question. Wind flows don't are not part of the synoptic variability. Synoptic variability includes a whole range of different processes. Well, I don't concentrate much on synoptic variability in my work. Any other questions? Vasily Vasilievich, please.
Дмитриев Василий Васильевич. Nikita Valerievich.
Nikita Valerievich, I totally agree with you that the model of and the progress of the transport of heat and salinity condition in some areas the zones of bioproductivity. In which direction would you take this idea to confirm this idea? What would be the first step in this direction? Yeah, is that clear? Thank you very much for your question. Very interesting, good question. At conferences, I exchange views with those people who study productivity. The most interesting way is to use the data of Argo boys. Well, the coverage is not sufficient for a large-scale study, but we'll use this data for productivity and biogens as well.
Хлорофилла.
Different senses on boys. There are two. You can approach it in two directions. The first thing you can say, I will find the zones, confirm this where we think they are, and the second one would try to build a model that would account for the primary bioproductivity. Any other questions from members of the Dissertation Committee who are online with us? Colleagues? Then I will ask a question if they're still thinking. On page 16 you say mesoscale vortexes have horizontal dimensions that exceed Rossby waves. Why do they exceed? In many theoretical works, it says synoptic vortexes are comparable with the internal radius of the deformation of the Rossby waves, and you have the opposite. In theoretical works, Barak line radius are the reference vortexes, but in reality, the vortexes in Lofoten basin are much higher, much bigger. The radius is both in altimetry data and other data. Well, this is a contribution of the practical and theoretical contradiction. Kamenkovich and Moni for tropical zones, they calculated 50 kilometers. In your regions, the distance is much lower because those are tropical regions. Denis Alexandrovich, you study shelf waves in the Australian basin. Why no vertexes there? Well, the shifts of the velocities are there, but no vertices. Thank you very much for your question. And the shelf zone, specific conditions are formed to create a different type of low frequency variability. This work has been carried out. Why did I take initially the shelf area? If we look at the altimetry fields and identify vortexes, both in the open ocean and the shelf, the same vortexes are identified. But the analysis and methodology show that the shelf zone has a low frequency variability of a different type.
Образованию шельфовых волн.
And therefore shelf waves are created. In your work, and you interpret the wave waves as barocline Rossby waves. Why baroclines? Why? What's the maximal peaks in altimetry in these regions? Tens of centimeters. Yes, tens. Up to 50 centimeters. And you interpret this as barocline Rossby waves, although they're usually in currents, because they are horizontal cross waves. Why do you interpret them as not as barotropic but baroclinic waves? We are based on the works of the classical of Nesland and Kamikovic, who interpreted mesoscale vortices as baroclinic waves. The baroclinity includes vertical and density differences. There is no theoretical basis to coin a new name for this mesoscale structures. In foreign studies, nonlinear wave, the term is nonlinear wave that has been presented, but there's no accepted terminology here. And in your results concerning the Australian Antarctic region, you divide wave propagation on shelf wall waves easterly, and if you take southern of the shelf, you call them Rossby waves. To the south of the shelf, there's a southern Australian basin, the depth of which is 8 kilometers. and the spread of the depths is quite huge. Topographic waves in southern hemisphere must spread in the edges of this basin as the Rossby waves go into the west. Could those Rossby waves be also topographic waves? Have you checked that? No, we haven't checked. We just take basic terms, shelf waves, and in the open ocean, as Neslin as the vortexes of the open ocean. We just used the literature. Topographic waves were not considered. Alexey Vladimirovich Zemin, please. Alexey Vladimirovich.
Phone.
Can you hear me? Yes, we can. Good afternoon, colleagues. I would like to ask the candidate on the talk about Lofoten Basin and the vortex transport. It's well known anticyclonic vortexes are formed in the frontal zone of the Norwegian current. Cyclonic vortexes can form in any part of the Lofoten Basin. So how did you account for that? We have directional waves that come from the Norwegian current and sporadic cyclonic vortexes. So how did you take account for that in the treatment of vortex transport? Thank you very much.
В первом приближении транспорт был рассчитан достаточно.
The transport was roughly estimated. First, we took the contour. You can see on slide 16, and flow was considered through this contour, cyclonal and anticyclonal. We do not consider all the factors. As far as the vortexes, the conditions of formations and the movement need additional study. And this is an approximate a look. In the future, we'll focus on the cyclonic vortexes, the conditions of forming and moving. Because this is a mystery, it's not, it's understudied. Any other questions to the defendant? May I? Sergey Ilyich, please. I have a question. In your presentation about the waves in the Australian shelf, you used the phrase, this process is very unstationary because extreme values hugely exceed the dispersion of sound. Is that your assessment of the non-stationary? Is it a quality or quantitative assessment? of this random process. Thank you very much. This assessment is a qualitative one. As not stationary is the visual assessment of the graph for no statistical methods to assess the stationarity and non-stationarity have been used. Well, I also figured that was the case. It's very dangerous sometimes to talk about stationary and non-stationary character of phenomena. He used a very interesting data of the Argo buoys and gliders. On their basis, can we assess the trajectory of the movement of these buoys? And why, if it's possible, why did the trajectory of movement of the buoys, not the vortexes? They're observed by satellites, and you can see the trajectory of these buoys, and therefore, and the specificity, if they're move in a spiral way or in a loop way. Based on this data, can you do any precision? Well, it all depends on the use of this data. If a buoy gets into a vortex, then the trajectory is then assessed, and the trajectory becomes a spiral in a spiral form and in the direction of the west. But the vortex should be very powerful. The studies are done for Gulf Stream vortexes, and for Agales, the buoy can travel for a year. That gets into that basin and the vortices. To study the trajectories of buoys, I didn't want to. I don't think it's feasible. No more questions. Thank you. And then we turn to the next item on the agenda. The reviews from the Dissertation Committee members. I would like the candidates to answer after each review. There are 6 reviews from members of the Dissertation Council. No external reviews have been submitted. All 6 reviews are positive. All the reviews have been published on the website of St. Petersburg University. Therefore, I would like members of the Dissertation Committee maybe skip the stative part, maybe concentrate on the short assessment of the work and the critical remarks and questions.
Члену диссертационного совета.
Member of the Dissertation Committee, Yakovchev Evgeny Vladimirovich, Doctor of Physical and Mathematical Sciences of the Norwegian Institute of Maritime Studies, Norway. Evgeny Vladimirovich, please. Nikita, you please take a seat.
Добрый день.
Dear colleagues, I was very interested to read this paper. It's not my area, but it was written by a very good language, and this reminded me of some things. And I even had to study some studies. My review is positive because the relevance of the issues are there. and about the transport of vortex, the induced transport of heat and salinity. There's a problem. Well, there's an issue how biogenic instruments or bodies cross these areas. And I would like to mention that some terms were used before they were deciphered. And so that's all. I loved the work. My review is positive. Evgeny Vladimirovich, thank you very much. There was one critical remark, yes? Please reply to this. Thank you very much for a review. And just some drawback in terms of writing up the text. I accept it fully. Thank you for the reference to the article. And I looked at this work, and it was very interesting. I really enriched my horizon. Next, the review by a member of the Dissertation Committee, Dmitriev, a doctor of physical mathematical science, geographical sciences, St. Petersburg University. Thank you very much, dear members of the Dissertation Council and the candidate. I'm very happy to participate in this session because I graduated with a degree in Oceanology from the Department of Oceanology, and I understood the content of the work and see the avenues of development and probably write up some recommendations. It's a 7-page review. I will just cover key issues. The work is original research. I looked at anti-plagiarism because currently the treatment of the results, the work complies with the requirements of St. Petersburg University, so the work is original. I'd like to also emphasize for those who are here, you should publish works. You have to have a baggage of published material. But also, when you refer to this work, if you use anti-plagiarism, the originality of your text will decrease. This is a big problem in the future, and we'll see how the attitude to this percentage of originality will change in the academic community. The main goal of this thesis is the satellite altimetry data. The title of the work doesn't make it clear the synoptic variability or what phenomena we're talking about. The object of study is a bit too long. 3 sentences that are the subject, that present the subject of study, and they're very hard to reproduce. Maybe I would have changed the formulations of the object of study. The structure of the work is vulnerable to, in my opinion, candidate or doctoral. You can limit to 3 main: the theory and methodology of the problem, the second methods your methods, your original methods, if you have patents or algorithms. And the third is approbation of your confirmation of your methods in practical realm and fundament, either basic research or applied research. If we look at this work from this perspective, the author tried to work in this way, but but it shifted. The author divided the empirical studies into chapters by region. Well, for these chapters could have been merged into one. In general, I like the work. I like the depth and the maturity of this work. While the author himself is very young. If the author so wishes, he can continue this work with great success. It's based on 3 grants, and it's very important. And it's very important that the applicant was the winner in 3 contests of the postgraduate student research works. 2018, in the Institute of Oceanology conducted, and 19, and this means that he was able to check the results and build a trajectory of his research to maximize the results. 5 Scopus papers and 6 ministry peer-reviewed list. This is a complete work, totally conforms to the requirements of this special the degree field, because in every degree field has a certain scope of research issues, and so there's a passport of the academic field, and this dissertation completely conforms to this passport. The defendant deserves the academic degree of Candidate of Geographical Sciences. Thank you very much. Nikita Valerievich, please address these critical remarks. Thank you very much for your review. Anti-plagiarism. I studied your report. There's another aspect. It's very hard to check to the level of references, because it refers to a lot of my own research, and so it's very hard to take account of that as far as the structure. The pre-defense, there are some reviewers that suggest that there are some structural changes. I will just say a structure is not ideal. We can work on it and improve. But one thing in all the and the reviews and the comments differ and that contradict each other when they talk about the ideal structure. So this is a structure that there is, and I tried to optimize it, but it can be improved, of course. Thank you very much. Any other questions? No, yeah. Well, your key, when you create a work on based on a lot of publication, you have to formally join this publication and create something new. Maybe you should reorganize something. So, thank you. Thank you. Vasily Vasilyevich, you looked at the presentation and his the short. What is your short assessment? I see a very good prospect for this work based on the data that has been collected here.
На примере мировой
First, bioproductivity in the world ocean. This is global warming induced direction, and this resonance effects, non-linearity that contributes to this. There are some zones of tolerance in chemical composition of the seawater and the biota. This all is very interesting. As a continuation, as a follow-up, I see a lot of opportunity to generate new knowledge. If you continue this, it was a shame that geoinformational support didn't find their way to the work. Now we talk about oceanology, and so the slides here have very interesting various graphs and figures. I think this is not the last work. Now the floor is given to members of the Dissertation Committee. Zimin Alexei Vadimovich, Doctor of Geographical Sciences, Professor of the Oceanology Department of St. Petersburg University, and Research Fellow of Sheshov Research Oceanology Institute. This work, I got acquainted with it much earlier than today. I thought at it as redundant. So waves and vortexes were put into one basket, and no geographical topology to bind. But and then the candidate has worked on it and combined the data into this very good dissertation. Nikita Valerievich reworked his work, the structure of his work, and the defense. The work sees the defense now in a different form than it was presented to the department. So it's very good that the author listens to criticism and is able to rework the whole work. enlarge or augment something. I'd like to say that 7th chapter, despite what's used logically, is a bit detached from the main part of the dissertation. But this is what we have. I will not spell out all the recommendations and critical remarks. The candidate can redress them. These are just about nuances of the work that don't diminish the value of the work. The dissertation produces a very positive impression and meets all the requirements. And we see that here we have a fully fledged researcher who deserves the third degree.
Пожалуйста.
Thank you, Nikita Valerievich. Could you answer these critical remarks and recommendations? Alexey Vladimirovich, thank you very much for your review. For the previous remarks, the Department Defense, this contributed to the final result.
В плане работы фигурирует понятие динамической активности.
The work, the dynamic active work, area, we understand that this is where variability has a wide range. The second term dynamically active regions and worlds appears to the title. For this purpose, in the same areas are named regions have a different dynamic activity. What's the reason for these discrepancies? The terms are identical in meaning. The only reason for the discrepancies, the author decided to add stylistic variety to the text of the work. And I think I may accept that it's not acceptable in terms of terminology. Third one, to understand the quality of the obtained monthly climatology of composite eddies, it's necessary to provide quantitative estimates of the distribution of TS profiles in the same way as shown in figure 2.4. Well, the distribution of selected profiles of temperatures and salinity in the normalized coordinate system is shown, where each selected profile's own monthly climatology was calculated based on all the profiles recorded, the distance of 2.4 radius from the selected eddy in a given month for the entire observation period.
Ну и мне визуализация данного процесса представляется крайне сложной восприятие.
Visualization of this process is very difficult for user to comprehend, and therefore I didn't include it. The third one, Chapter 3 describes the results of low latitude Indian Ocean region. What is it? There's even mentioned Chapter 1 and 2. What's the reason for this discrepancy? This region is not the main research area of the presented dissertation work, and is given in the dissertation for comparison. Section 4.4 requires clarification of the reason for the discovery of a cinder in the composite vortex in region 2. Is it a physical nature, or is it related to the peculiarities of the test selection of the composite vortex? The study of this issue is planned to be carried out separately in a future study. We will study the symmetry of the eddy for each cyclone. No, I cannot answer this question right now. As far as the asymmetry of the vortex in Luften region, you said the section 5.2 states the symptom of the eddies was the observed structure as a characteristic feature of the mesoscale eddies in the Lofton region due to the pronounced zonal gradient and the temperature and salinity of the entire area of the Lofton. However, this is not entirely correct, since it is in this region, under the influence of powerful currents, that the zoning of temperature, salinity gradients inherent in most of the world ocean is violated. You see the endpoint a figure for A shows the distribution of the sea surface temperature averaged over a very short period from July 12 to July 19, 2002, while the dissertation analysis are composite vortex related as a result of averaging a large number of profiles obtained for the period between 2000 and 2017. So the composition is not entirely correct. But of course, this should have been explained better. As far as an increase in the radius, chapter 6, there's a phrase, an increase in the radius of vortices accompanied by decrease in its amplitude. Could it be due to the peculiarity of the automatic identification procedure? Due to the limited spatial resolution of our altimetric fields, there are limitations in the possibility of errors in determining the radius and amplitude of vortices. The limited factor is also the temporal resolution of the altimetry data, which leads to the possible errors in the vortex tracking algorithm, leading to the algorithm being able to treat two different vortices as one. These questions are outlined in the article by Shelton and al., 2011. To talk about it in detail, you can see in the Visa website next year we'll see that launched, and I agree with the technical remarks. Thank you very much for your close attention to the text, both at the stage of the pre-defense and at the defense. Thank you very much. It was very productive interaction. Alexey Vladimirovich, are you satisfied? Yes, I am satisfied. Based on the presentation, on your, would you like to make a short evaluation of the work? Despite some gaps and redundancy of some chapters, structure and semantically, the dissertation is logically structured. The defendant answered all the questions very well. I'm totally happy that the work deserves the degree. Then the next review. Members Badulin, Doctor of Physical Mathematical Sciences, the Institute of Shashov Institute. Thank you very much, dear colleagues, for this opportunity to speak at this wonderful session. It's a very positive experience for me. This form of work with the dissertation, with the candidate, is very good. The specialists that are interested in this field are present, and there are a minimal number of people who are present, who must be there due to their position. I think that this is very productive discussion. I highly evaluate this work because it conforms with the specialism ocean geography and narrow field oceanology. A geographer should be capable of systematize divergent pictures of interaction of different phenomena. Nikita Valerievich was successful in doing that. He looked at different physical process from a single point of view. He looked at it as Rossby waves, or the phenomenon that look like Rossby waves from a mathematical point of view. That has to do, well, the shelf waves.
Работа удачной. Но, с другой стороны, у меня, конечно...
Therefore, I think that the work is absolutely successful. But I have some questions, mathematical and physical questions. There are some flaws there. I mentioned it in my review. One more. One more positive result of this work is that it has great prospects for development. I met Nikita Valerievich at a conference on altimetry in the Azore Islands, and he talked there about the shelf waves. So what he has in the dissertation is very interesting, but it's just the beginning of great work using this material and expanding the material in the direction of a more mathematical and physical description. I would like just to conclude that Nikita Valerievich demonstrated high qualification as a geographer, a little bit less as mathematician and physicist, but it's not his background, and I think that he deserves the third degree of Candidate of Geographical Sciences in Oceanology. Any questions to me? Sergeyevich, thank you very much. Please, your answers. Thank you very much. Thank you very much for your review. I'd like to say something in general, but I forgot. Some technical remarks about the orthography and the text. Of course, I agree with them. As far as the questions of hydrodynamics, that you cannot call it the law of the energy keeping of this energy. In some textbooks, it is actually called that. As far as the anomalous salinity, I used different parameters. They asked the salinity is as the modern treatment of salinity uses different parameters, and therefore I used the scales that is generally accepted today. There's a transition period between these two equations, and there's a mix-up, and a lot of literature that I have read. Thank you very much for the close attention to my work. Thank you very much for your comments. Sergey Igorevich, are you satisfied with the answers? I'm quite satisfied, although since we just talked with Nikita Valerievich a week ago at a conference of young scientists. Based on the answers and presentations, what is your conclusion? Short evaluation of the work. This is a good work, a good demonstration of the capabilities of modern altimetry, and presents new ways of working with this data. The candidate formulated very interesting tasks and fulfilled them. And this work shows the candidate's high qualification and the passion for research. He tried to step beyond the charted land into the uncharted land. The number of publications exceeds the average number of publications that we see at a Candidate of Sciences defense. Thank you very much. The next turn is Timokhov Leonid Alexandrovich, Doctor of Physical Mathematics, Chief Research Fellow of the Arctic and Antarctic Research Institute. The dissertation consists of 7 chapters and a very long list of sources. It's obvious that the topic of the dissertation is very relevant. The only recommendation is you should have paid more attention and explain that dissertation studies part of the synoptic variability that has to do with the shelf waves and the vortexes, because the name of the dissertation is too wide, and but in fact what is written about is quite narrow. The positive attitude, well, the second chapter I liked the most. Huge. I would like to mention that a technical break should be announced because Sergey Ilyich left us. That he's not accessible. Therefore, we have to declare a technical break.
Так, ну ладно, выпьем воды тогда.
Так, заканчиваем технический.
Technical break is announced to be closed. Good impression also of the third chapter about nonlinear and linear vectors based on altimetry data, satellite data, and the fourth chapter gives new information about the specificity of the spatial distribution of vortexes in Agalas current and the duration of life. It's very important research, very good study. Just one more.
19.
In 4.19, you showed the figure has a black and white depiction of the vortexes, and the previous figures has color pictures, and it's much better to understand what's going on in the color pictures. Norwegian Sea is the key area for heat delivery in this area. The results that have been achieved allow us to understand better the formation of vortexes in this basin and its impact. In chapter 6, where mesoscale vertices are studied in Australian and Antarctic area, well, this chapter is a bit less academic, but the research data is still very interesting. The shelf waves in the Australian Gulf is very interesting. The data is very interesting, and maybe this is a recommendation for the future. Why in this region? Why do you not see vertex phenomena? I think that there must be some vortex barotropic and baroclinal phenomena. Well, if you don't see them, then maybe we should study that in the future. The dissertation fully conforms with the requirements of St. Petersburg University about the granting of Candidate of Sciences degrees and Doctor of Sciences degrees. So the candidate deserves the sought degree. Nikita Valerievich, please answer. Thank you very much. The technical, I will address the technical remark about the color. When the PDF file, when you work with PDF files, shouldn't exceed a certain amount. So the file with the whole dissertation, both in the English and the Russian version, when I had to restrict the file to the threshold level, I had to compromise the color in some pictures, and this is unfortunately was unavoidable. As far as the shelf of the Australian Antarctic region basin, we will continue this work. As far as the sixth chapter, maybe it's an outstanding one in terms of the scale of the work, but this chapter was the first one that I did wrote at the beginning of my work on this dissertation. Maybe it has turned out a bit oversimplified. Thank you very much for your remark. Sanj, do you agree with it? Yes, I do. Then your short conclusion. What you heard from the defendant, and very short assessment. The dissertation is an important work written, carried out at a very high research level. The candidate worked with a lot of observations, and the results are very relevant, present a new understanding of the synoptic variability of the old ocean due to vortexes and shelf whales. Of course, I support granting the third degree to the candidate. I have one more review. There's mine. I'm the chairman of the dissertation committee, Sakharchuk Evgeny, doctor of professor of the and head of the department of Oceanology at St. Petersburg University. I would like to say that it was a very interesting work for me to read. It has to do with it crosses my research interests, and therefore I have more remarks and recommendations than other members of the dissertation committee had. To shorten the time, I will just read out the referring to the theoretical work, mainly Neslin tries to convince readers that mesoscale eddies and Rossby waves are manifestations of the same process. However, the arguments given by the author to confirm this interpretation cannot, in our opinion, be called convincing. I quote, "The same system of hydrodynamic equations describe not only vertices of Rossby waves, but also many other processes in the ocean atmosphere." And then the applicant notes that the existence of mesoscale eddies, Rossby waves, is due to the same reasons, the rotation of the Earth and sphericity. But theoretically, mesoscale eddies can be generated, exist on a flat Earth, while Rossby waves cannot. When there are no, of course, synoptic eddies sometimes reveal some features of Rossby waves, namely propagation from the western component of the phase velocity and a good quantitative coincidence with the space-time scales of oscillations of the dispersion or rotational describing Rossby waves. Also cannot be called convincing argument. In many regions of the world ocean, eddies move from the eastern component of the velocity, and their sizes are noticeably smaller than Rossby waves. Also, I would like to say that the author's thesis that mesoscale vortex activity, one cannot agree that with this author that for theoretical physicists, the question of how to name these objects, waves or vortices, which are described by solutions of Laplace's places, questions of the second kind, is not of primary importance. The identification of waves, vortices, is still the primary problem of the theoretical description of the synoptic variability of the oceanographic fields. The author's thesis that mesoscale vortex activity is one of the main mechanisms of the horizontal mixing. Its mesoscale eddies have a significant impact on vertical mixing in the ocean. It's impossible to fully agree with that, I quote, the results of the presented dissertation. Research can also be used to assess the biological productivity of waters, which is significantly influenced by mesoscale cyclonic eddies. As page 9 of the Russian version, it has long been known that in commercial oceanology that anticyclonic eddies can also have a great influence on commercial productivity. Remember, Shatokin wrote about Turin. To the disadvantages of Chapter 1 include a very poor definition of Rossby waves given on page 16, which doesn't give the reader any idea of the wave-forming mechanisms of these waves. Page 17, the well-known formula of the inner radius of Rossby deformation is presented, and only reference is made to the work of Belenenko and Novoselova. It seems that they are the first. Looks like they were the first to deduce this formula, which is not true. It is regrettable the applicant did not verify the satellite altimetry data by comparing them with coastal and level measurements in order to study the capability of the satellite information archive, its limitations and disadvantages. For example, for the Baltic Sea and the interpolation, as this invention of the performed analysis, one can point out the estimation of all characteristics of mesoscale eddies only in the stationary approximation. In Chapter 3, a methodological error is also the estimation of the phase velocities of shelf waves using the maximum correlation method. Estimates of the phase velocities of waves obtained using this method are in order of magnitude lower than the theoretical phase velocities of shell waves, calculated from the dispersion waves relation on page 184. Well, this means that taking into account the process of vortex formation, evolution was pronounced no stationary random process. The results of Shelton and are in contradiction to some altimetry data in different regions, in the tropical zones and the Southern Ocean. There's a wave structure of tribulations, and the results are also contradictory to the Boy's trajectory, because this is due to the court said that these loop shaped buoys are talk about different profiles. I would like to agree with the candidate that in the world oceans there are regions where synoptic vertices dominate. For example, the regions of western border currents, some regions of the Southern Ocean, some, and where the trajectories of drifting of buoys, you can see spiral movements, and some segments are spiral movements and some other loop movements, and means that there's a capture of water by vertex phenomena. But in most other areas of the world ocean, these results, waves dominate in the synoptic range. Why why such contradictions? Maybe a methodological error was made. Then, because the phase velocities, you looked at the seasonal fluctuations of levels. The author thinks that these currents have to do only with vortices and Rossby waves. But every wave has a dispersion value. For low frequency waves, all the parameters should be accounted, or should be considered in a different way. The ratio of the velocity and the in equation 2 only undivergent waves of Rossby are accounted for. These other types of wave movements can make a great impact. The candidate, based on the literature, provides a hypothesis that the relief, the underwater relief has an impact. And as far as the stationary approximation, the evolution of vortices is a non-stationary process. So the characteristics should be these characters should be accounted for. When you describe 4.11 figure, you say that you describe the movement of the water incorrectly. The interpretation of on page 6.2 and 68, there's a wave structure of the movements, and they're close to the baroclinic Rossby waves. The advantage of this discussion is chapter 7, very interesting remarks are presented based on this. These results expand our understanding of the nature of waves, but you on page you put the baroclinic Kelvin waves to a different type of waves, although the shelf waves on page 6, page there are some very few typos. The contribution of nonlinear and linear process into what? On page 70, the redundant word is captured in relation to the shelf waves, because they are captured by definition. You don't need to apply this term. Page 36 in the legend to 2.3. There's no information that what the highlighted shape on page in figure 2.3a actually means. As on the whole, my review is absolutely positive, and the candidate deserves a high degree of the Candidate of Geographical Sciences. Evgeny Alexandrovich, thank you very much for your. There are very many of them. I will not read all of them. Just in short way, first one that refers to Neslin's definition. Well, we do not see any contradiction in the remark and agree with the hydrodynamic equations describe many other processes in the ocean atmosphere, except for Rossby, in addition to Rossby waves and vortices. Second one, and there is no contradiction in the remark either. The opponent obviously had in mind the F-plane approximation, which is used to study vortices, and for Rossby waves, the beta plane approximation must be used. Internal vortices can be considered both without the F-plane and without the beta plane. For example, Rakin's vortex. Well, terminological maybe it's not totally accurate.
Тоже сильного противоречия нам не видим.
The next is synoptic eddies sometimes reveal some features of Rossby waves. Well, it cannot be a convincing argument. There's no contradiction in this remark either. We write the following: sometimes they find this is true, and this fact is confirmed by many publications in high-rating journals, for example, and in Charlton et al., 2011. However, the other factors are taken into account, for example, when interacting with shear jet streams, such as ACC, or large-scale topography. Other facts should always be taken into account. This is indicated not only in the works of Kamenkovich and Charlton, but also in many publications in recent years. Chernyshев, Frolov, etc. Second one that you don't agree with it for theoretical physics, the question of how to name these objects, waves or vortices. With a quote from Kamenkovich, we completely agree. But it doesn't follow from that the question of identifying vortices and waves is really of paramount importance. Moreover, the definition is qualitative in nature, not leading to quantitative estimates. This next one is vortex activity, so one of the main mechanisms of horizontal mix is limited. We totally agree with it. In addition to horizontal mixing, vortices have a significant effect on vertical mixing, but it should be borne in mind that usually the horizontal velocities in vortices are at least 3 orders of magnitude higher than the vertical velocities. The next one. It is impossible to agree that the results of the presented dissertation can be used to assess the biological productivity of waters. That it has been long known that commercial oceanology that anticyclonides have a great influence on commission. I totally agree with this remark. Anticyclones have a significant impact on the biological productivity of seawaters. As far as the poorer definition of Rossby waves, page 60, has to do with theoretical questions. To study it, you can write a whole new dissertation. Description of waveforming mechanism is not the purpose of this dissertation. The reference to the article of Belanenko and Novoselov is given only because it contains specific estimates of the baroclinic deformation radius that are required in the future, specifically for the Lofoten basin. Maybe I should have referred to more classical works. That's the next one. The applicant didn't verify the satellite altimetry data by comparing with the coastal sea level measurements in order to study the capability of the satellite information archive. This limitation distinguished. That's very good. Good remark. Assessment of the quality and validation of altimetry presence is a separate large-scale task. It's not the purpose of the presented dissertation research. Such work is being carried out within the framework of individual projects of scientific agencies that are engaged in the development of altimetric arrays, and particularly the French scientific agency in AES is conducting detailed studies comparing altimetry measurements with the data from coastal level gauges of different regions of the world ocean. The results of the studies are available at aviso.altimetry.fr. It should be also noted that similar study for the Norwegian Sea has already been carried out within the framework of the Russian Science Foundation grant 18/027. Results are published in Naumov and et al. In the Advances of Space Research. Long remark on Chapter 3. Results demonstrated as well as the results of Chapter 9 come into conflict. I think that there's no contradiction, and we adhere to the modern view of one point of view that the criterion U/C more than one, where U is the azimuthal velocity of eddies, and C as the velocity of their movement, is fulfilled for most regions of the world ocean. The opponent, however, refers to the analysis of data from 300 surface, free drafting buoys, Southern Ocean. These works, the criterion of non-linearity was not evaluated. As far as the non-stational approximation, methods of statistical modeling of random process obviously can be applied in mesoscale eddies, but this approach was not a priority for achieving the goal of the study. As far as the nonlinear potential applied to Rossby waves is estimated incorrectly. The answer is we draw from the work, on the work of Neslin, Charlton, and so the correctness was not, we didn't face it. And this question of correctness, of course, can be studied. The next methodological error is the investigation of phase velocities, shelf waves, using the maximum correlation method. The estimates of the phase velocities of waves obtained during this method are in order of magnitude lower than the theoretical phase velocity of shell waves. Indeed, the method of maximum correlation showed the estimates of velocities which are in order of magnitude less than the phase one. But this method does not estimate the velocities of a monochromatic wave, and its estimates refer to group velocities. For our work, this method made it possible to identify areas of dominance of shell waves across Rossby waves. And then there are some technical remarks. I totally agree with these. There's one. Maybe I should return to the slide. I should have emphasized that in the presentation. About this rectangular shape. What is it? This is a location of quasi-stationary Leviton vertex, which which is a specific separate phenomena, and we didn't tackle it. Thank you. Thank you very much. I'm satisfied with the answers. And on the whole, I would like to say my evaluation of the work is positive, despite the fact that I had a lot of critical remarks. In my view, some provisions are controversial, but this is a good thing, because the author drew upon serious works published in high-level journals. So this ideology is viable. The candidate dissertation. There's a qualification work, and the candidate showed a very high qualification in data processing of the oceanology data as satellite and contact information, in situ information. New results were achieved that will develop our understanding about the synoptic variability of oceanological processes and fields in the world ocean. I support this work, and the candidate deserves to be awarded the degree of Candidate of Geographical Sciences in Oceanology. Thank you very much. Evgeny Vladimirovich, I would like to address you based on the answers of the defendant. Please make a short assessment of them. As I said, I enjoyed the work, both in style and it has great potential. 3D graphic models exclude horizontal turbulence, but when modeling the transfer by gene elements, the model doesn't allow to transport an element in a horizontal plane, but this work shows that it is possible. I endorse the resolution to grant the third degree. Well, then we finished the reviews. Open floor for anyone who's present here. Do we have any one who would like to speak up? No takers. No takers. Then we need to read questions that we have received through the. Do you have any questions? No questions. Then, the next, the research advisor, Tatiana Vasilevna Belonenko, Doctor of Geographical Sciences, Professor of the Department of Oceanology, St. Petersburg University. Good afternoon, members of the Dissertation Committee. I would like to thank the members of the Dissertation Committee for being willing to become reviewers and close attention to this manuscript. And I'm very happy that there's been a debate, because this means that this topic is a live topic and concerns a lot of people. Well, there can't be anything ideal. Well, as my colleague said, you can even find flaws with a lamppost. Well, Nikita Valerievich Sandalyuk is a graduate of the Department of Oceanology, St. Petersburg University. After completion of the studies in 2016, he entered a postgraduate study department. When he approached me in 2016, I hadn't known him before, asked me to become his research. He knew nothing about the synoptic variability, or mesoscale vortices, but thanks to his single-mindedness and hard work, it took him very little time to cover a long distance. This work has to do with physical oceanography. You have to work with large arrays of data. This is not mathematics. This is a skill to use other people's data in theoretical and analyze satellite empirical information. He studied MATLAB programming system, and he learns how to work with big data and the data of gliders. Russia has no gliders. Nobody can work with such data. Nikita read some technical texts and he understood everything and how this data worked and how it was used for the analysis of oceanographic situation. Nikita Valerievich works as a teaching assistant in the Department of Oceanology, part-time. This defense will increase the level of qualification of the department. He is good at analyzing big data, and this is what he's going to teach to our students. When he first started studying the material on the topic, I included him into the grants that were running Russian Fundamental Science Foundation, and now he participates in another grant that's ongoing. And all the papers have an acknowledgement that this was supported. The work was supported by this or that grant. I would like to say that Nikita Valery Sandalyuk has great potential in science. My opinion is totally valid, and I would like to ask members of the Dissertation Council to vote for the conferral of the degree on Nikita Valeryevich. Colleagues, do you have any other comments? No. So the discussion is over then. And before we conclude and vote, I'd like to ask a question. Are there any objections or procedure-wise? For example, technology, anything? Okay, good. Then voting. We can announce a break and switch off the broadcast to discuss the results. Do we need to do that? No. Well done. Then we'll check if we can hear each other. Is there a connection? Can you hear me in an online mode? Yes. Then I put to the vote the resolution to award the academic degree of Candidate of Geographical Sciences in the Oceanology. This is an open roll call vote. Remind you that positive, the verdict is positive, is more than, is legitimate if not fewer than 4 members of the Dissertation Council vote in favor. Dmitry Vasilyevich, your opinion? I agree with conferring the third degree on Slobodanuk Valery Zimin, member of I vote in favor of the awarding of the third degree. Baduly Sergeyevich, I endorse the decision to grant the Candidate of Sciences degree. Timokhov Leonid Alexandrovich, I endorse the decision to award Sandalyuk, Candidate Sandalyuk, the third degree, and member of the committee Yakushev. I am in favor of granting the third degree. Thank you very much. Chairman of the committee also support this decision. Thank you very much. Dear colleagues and guests, I announce that out of six members of the Dissertation Council, 6 members vote for the resolution to award the degree. No abstentions, no one voted against. Therefore, the decision to award Nikita Valerius Sandalyuk the academic degree of Candidate of Geographical Science in the degree field 25/028 Oceanography has been taken. Concluding statement. Thank you very much. I would like to thank my academic advisor, Tatiana Vasilyevna Belanenko, for motivating me, for taking me through very important and contributing to my development as a scientist. I'd like to thank the Department of Oceanology for the support, for a very fruitful discussion and before the defense and at the defense. Thank you very much. Thank you for accepting my invitation to become reviewers of my dissertation. Thank you very much. My friends too. Thus, please round of applause to the candidate. The session is therefore officially announced over. Thank you very much.